Alright, I'm back. Lesson 92, simplifying complex fractions. Basically, all a complex fraction is a fraction divided by a fraction. Now, I know when we get letters involved, we tend to get scared, but hang in there. You're going to be able to do this, I promise. So, first of all, you could get a complex fraction that looks like a over b over c over d. And just at first glance, that kind of just looks like a bunch of letters stacked on top of each other. But we know that fractions can be written as division statements. So we can write a over b divided by c over d. And we all know how to divide fractions. We multiply by the reciprocal. So that's the main gist of what's going on today. So let's just try an example like this. Okay, we've got a over x divided by b over a plus x. First thing we're going to do is write this as a division statement. A over x divided by b over a plus x. Okay, now we know that if we divide fractions, we have to multiply by the reciprocal. So we write the first one down, change the division to multiplication, and flip over the second fraction. And this is our new problem. Okay, from here, none of these letters match up, so we can multiply these. So if we do a times a plus x, there's really nothing to simplify there, over x times b. There's no numbers, there's nothing we can simplify. So that would be our answer right here. Okay, so sometimes it's just a matter of writing them all on the same line. Do not stress, you will be able to do this. Okay, let's try another example. We've got am over n divided by x over mn. So we're going to rewrite that as a division problem. Am over n divided by x over mn. Then I need to flip over the second fraction. Change division to multiplication. Okay, now there's a couple things that happen here. Thing number one, I've got n, a diagonal from n, so I can cancel those out. Then, if I multiply straight across, I don't have any other a's, so I can write down a. M times m is m squared. And down here, the n canceled out, so all that's left on the bottom is x. So we should have am squared over x. Okay? Stay with me here. I know it's going to get more complicated and we're going to get stressed, but we're going to make it through it. Alright, so we've got, sometimes we're going to have to factor to simplify. I know we all love factoring. It's one of our favorite F words along with FOIL. 3x over 6x plus 12 divided by 9 over x plus 2. Same thing. First thing you're going to do is write this as a division problem. 3x over 6x plus 12 divided by 9 over x plus 2. Okay? Again, the next thing you're going to do is flip over the second fraction. So we've got 3x over 6x plus 12 times x plus 2 over 9. Here's where the factoring is going to happen. In this 6x plus 12, I can factor out a 6, and I'm left with x plus 2. Okay, so now I have a few things that cancel out. We've got x plus 2 on the top here, diagonal from this x plus 2, so those are going to cancel out. I've got 3 diagonal from 9, so this can turn into 1 and 3. Now, if I multiply straight across, 1 times 1 is 1, over 6 times 3 is 18, and we've still got this x here, so x has to go on the top. So we've got 1x over 18, or you could just say x over 18, okay? There will be things that can cancel out. It's going to be okay. Let's look at another example like that. Here we go. Here's a good one. We've got x squared minus x over 9 divided by x minus 1 over 3x. First thing we do is write this as a division problem. X squared minus x over 9 divided by x minus 1 over 3x. Well, let's flip over that second fraction and switch to multiplication. So now we're thinking, can I factor? We flipped, now we got to factor. So here in this x squared minus x, I can factor out an x, and then I'll have x minus, well, if I take out the x, all that's left is 1. Okay, we replace that with that. So here we go again. We've got x minus 1 across from each other. We've got 3 and 9, which we can simplify to 3 and 1. It looks like that's all that we can cross out. So now I'm left with x times 1 is x over 3 times 1 is 3. So our answer is x over 3. Remember, you can pause the video before the answers pop up so that you can try and do these problems on your own. Then you can always check your work with the video afterwards. Whatever works best for you, but just be following along, taking good notes so you know what's going on, okay? Okay, this last example is probably the most complicated. I know you guys always hate it when it gets harder as we go, but I am going to put some extra resources in the module to go with this lesson, just so you have like some more places to get help if you need it. And remember, you can always Zoom me if you need to. Send me a message on Remind or on Canvas, whatever works, and I will help you as best as I can. Okay, so this last example is combining fractions. So if we have 1 over x divided by 1 minus 1 over x. Okay, I know it's freaking you out a little bit because these are not both just one fraction. What we are going to do is we're going to take this 1 and we want it to have the same denominator as this x over here so that we can write it as one fraction. Well, if I want the bottom to be x, so 1 equals something over x. If I want the bottom to be x, the top has to be x, because that would x over x equals 1. Okay, so we're going to change this 1 to x over x. So then it would be 1 over x over x minus 1 over x, which we can rewrite that bottom part as x minus 1 over x. So now we just have 2 fractions. Okay, so if I rewrite that, I've got 1 over x divided by x minus 1 over x. My next step is to flip the second fraction. So I've got times x over x minus 1. Well, right away here, I can cancel out these x's that are diagonal from each other. And I end up with 1 times 1 is 1. 1 times x minus 1 is x minus 1. And that's my answer. Okay, we're going to do another one of these examples so that we make sure we're clear on it. But I really think you can do this, guys. Stick with it. Okay, here's our other example. 1 minus 1 over x plus 1 divided by x over 2x. So now, when we add and subtract fractions, think of it like your common denominator. We want this 1 to have the same denominator as this fraction. So if I have 1 over minus 1 over x plus 1, if I was trying to add and subtract fractions, I would take this times x plus 1 over x plus 1 so that I get that same denominator. That's all we're doing. So if I take 1 times x plus 1 over x plus 1, this is going to be x plus 1 over x plus 1 minus 1 over x plus 1, which we could simplify because x plus 1 minus 1 is just x over x plus 1. So now we've simplified this top piece of the fraction into this one easier to read fraction. So let's rewrite our problem using that fraction. So we've got x over x plus 1 over x over 2x, which our division problem would be x over x plus 1 divided by x over 2x. Flip the second fraction. So now we have times 2x over x. We've already got things that cancel out here. We've got this x across from this x. Then 2x times 1 is just 2x. Right? There's nothing left on the top. And then x plus 1 times 1 is just x plus 1. Okay? We cannot simplify these x's because this is like a set of parentheses. So since it's not x plus 1, we can't simplify that. This is our final answer. Okay? You should have everything you need to go ahead and try the homework. There are extra resources available to you if you need them for this lesson. If you need anything from me, make sure you're getting a hold of me. I am here to help you. I will see you hopefully soon.